So you have notes that we're going to look at direct variation, and I asked you to fill in as much as you could with the book and prior knowledge. So the review here, we'll cross out the ratio. So as you can see, a ratio is just a fraction or division, and it looks to be that we have a few here that equal. We can see 3.5 over 1 is 3.5, 7 over 2 is 3.5. 10.5 over 3 is 3.5, but 9.4 is not going to be equal to all those other ones. There's a couple ways we can solve the proportions here. If we look at this, we can say that's times 3 to get to 9. So if we're going to be equivalent, it has to be times 3 to the denominator as well. So x should be equal to 6. Another way we can do this is do the cross product. We can take 2 times 9 and set that equal to 3 times x. You get 18 equals 3x. Divide. And we get x equals 6. Same with these other three. Let's just do this one. So x over 3 equals 16 over 12. If we look at the denominator, it's going to go times 4. So we should do x is equal to 4 on the top. If we look at the cross product, again, we can say 16 times 3 equals 12 times x. And then we have 48 equals 12x. When we undo that, divide it by 12, we'll also see another way here to get x equals 4. Do the next two if you haven't already. So you're not always going to get a nice clean answer. Like in number 4, this decimal actually continues. So I can say, we can also leave it as an improper fraction as 10/7. So we couldn't clearly see that that's going to be times 10/7. Here we can clearly see that we're going to multiply by 2 as a common factor, and we get that. Moving down to vocabulary, the main idea here is direct variation. So direct describing two quantities that vary in the same way, either increasing together or decreasing. So we can see in direct variation that they have to increase or decrease. If we take a look at these, correct options here would be directions. The fans went directly to their seats. And then there was a direct connection between the team scoring and the fans cheering. So those would be variables that we'd be comparing. And really what we're saying is there's a connection. And that's varying directly. Let's look at problem 1. We look at this problem. We're trying to see if y varies directly with x. So we got to take that from the beginning, that ratio of y compared to x. The ratio is just a fraction, remember. So in this first one, we're comparing the x and the y value, but notice the x is on the denominator and the numerator is negative 21. So you can see that's negative 7. So we want to check and see if all of the y's compared to x give us the same thing. That's going to give us negative 7. We know that's y, and that's x, and that gives us negative 7. So we can say, since the ratio y over x is the same for all the inputs, the function is a direct variation. Now, the constant of variation looks like this. So you're given basically an equation that looks like y equals k to the x. K to the x is your constant of variation, and that's what it's called. Now, as we compare that to this, or a linear equation, it's just the same as saying slope. So k in this case is negative 7. And then our function rule is just negative 7x. So our next type of rule comes in the form of an equation that's really not set up yet to take a look at. So if we have 5x plus 3y equals 0, this is called standard form of a linear equation. And that looks like this. Some number a times x plus some number b times y equals c. Now, it tells us to solve the equation for y. If we ever get a problem like this, this is the step. We want to isolate y. So I'm going to move some parts here and get 3y equals negative 5x. And then I'm going to divide by 3 because that's what's being multiplied. Now I have negative 5/3, which is a ratio, times x. And there's no other value with it, it's just that. So when we look at the choices for constant variation, remember, a direct variation is in the form of y equals k to the x, and k can either be increasing or decreasing. Negative 5/3, all we're doing is we're just identifying what the slope is, really, or the constant variation in this case. Alright, so problem 3 says using a proportion to solve a direct variation. So we want to see y, they're saying y varies directly with x, and we just have to prove that. So these are the two values that we know become a ratio. So the first thing we fill in is 15 over 3. And then it says, what is y when x equals 12? So those two are together because it's telling us that those are the ones paired up. We can see that it's times 4, and then this would be times 4 because we want to go by the same factor. So simplifying the proportion is what we looked at earlier up top, but using the cross product is a nice quick way to determine and solve. So we take 15 times 12 equals 3 times y. So we know 3y. We know 15 times 12 is 180. And all we're doing here is solving for y. So we divide by 3, divide by 3. And y in this case is going to equal 60. And we can also see that that's what would have been produced if we did 15 times 4. So when x equals 12, the value of y has to be 60 because it's saying this. It's saying it varies directly. So it has to be in the same, and it's the same proportion. And it looks like that. We're going to look at a problem here that is more of a word problem, but it's the same as the previous problem as far as how it's set up. It's saying the number of calories varies directly with the mass of cheese. 50 grams of cheese contain 200 calories. How many calories are in 70 grams of cheese? So it looks like we're going to take calories as our numerator. You want to make sure the calories go in the numerator up top. On the other proportion or the other ratio, we don't know it, so we're going to put a C. It's over 50. And then we know this is to 70 grams. And we can solve like we did before. So let's just start and look at the proportions as they're written. And we're setting these up. Any proportions that look like this with an equal sign, it's very nice to use this method of cross product. Now we can do that because the opposite of dividing by 50 is multiplying each side by 50. And it's the same with 70. The opposite of dividing by 70 is multiplying each side by 70. But notice that divides to 1. So what we're really doing is 70 times 200. So that's where this left side comes from. And then we know 70 over 70 is 1, so you're left with c times 50, which is where this part of the cross product comes from. Now we just did a product there. Divide by 50. So now we have c equals, and what we can do is when we do this division, when I do this division, I can take these zeros, and that's like dividing 10 out of it first. So I could think of it like 1400 over 5, which is the same proportion as 14,000 over 50. When I divide these two, I get 280 equals C. So calories should be equal to 280. Now compare that. 200 calories was to 50 as 280 is to 70. That seems like a logical conclusion. A good answer there. We know it's going to be over 200, but not too much. So 280 calories. So the last thing that you would be asked to do is graph the direct variation, and they give us this equation. So right now we already know the constant of variation is negative 2/3. So that's the factor. So this is really a factor. A constant of variation is a factor of the problem. So when we look at this, we have negative 2/3, and we're trying to multiply it by our first input value, which is an x value, so it's just substitution, negative 3. When we do this, I could do it a couple ways. I could do negative 3 over 1 is the same as negative 3, and the rules of fractions multiply the top, so negative 2 times negative 3 is positive 6 over 3. I could get 2. Another way to do this is to say, oh, negative 3 divided by 3 is negative 1, and then I could just do negative 2 times negative 1 and still get 2. So you want to use some of your rules. The next one's easy. You plug that in. Anything times 0 is 0. And then we have negative 2/3 times 3, which is the same as 3 over 1. And we could say, all right, 3 divided by 3, before we do any multiplication, we know that's 1 over 1. And we're going to get 2 times a positive 1, negative 2. So that gives us our coordinates. So here, we just have a list of coordinate pairs, and we can graph those. So negative 3, 1, 2, 3. Remember, first direction is left or right, and then the y value is up or down, so we go up 2. 0, 0, it's nice, easy. And then over 3, down 2. And we connect those, and we have our graph for the equation of y equals negative 2/3 x. I am going to leave the rest of this for you to take a look at, but I do want to say a few things. This third graph over here, notice how this is crossing through 0, 0. This is crossing through 0, 0. Remember, y equals k times x does not have, or it does have, it's a 0, but it always will pass through the origin. That's a property of direct variation. So notice how this one does not pass through the origin. So this would just be a linear function. It's not a special type of linear function, which is direct variation. That's a special type. And as we go through, we look at equations, you'll also notice that these equations, this one doesn't have an intercept, this one doesn't have an intercept, but this one does. So I'll leave it up to you to say which, if it's a direct variation, so write a D. If it's just a linear, it's not direct variation, write an L.